Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today we are back with our next problem of the day, which is prefix suffix string. So, please let me know if I'm clearly audible and visible to you all. Hi, Matbar. Hi, Risit. How are you guys? So, today our problem is prefix suffix string. It is a quite advanced string problem because it is based on the concept of try. So, for those who don't know try, it is going to be quite difficult because try is the prerequisite of this problem. By the way, I will try my best to have some introduction of try. I cannot teach you complete try topic in this particular live because it's not. It will take a lot of time, but but then also it's an important topic. I will have a quite introduction of try. Okay. No worries, Nekas. No worries. All the best for exams. Okay. Thanks. Hi, Oscar. Hi. Okay. Great. So let me share the screen and let's start today's problem of the day, which is prefix suffix array. So let me share the screen. I hope that my screen is visible now. Okay, great. So guys, the problem today is the problem statement is quite easy, that we are having two lists of strings, like two arrays of strings are given to us, and we have to count number of strings as 2, which is either a suffix or prefix of one string in S1. So you have to count ki how many, like number of strings in S2. You have to find number of strings in S2 which are either a prefix or a suffix of S1 strings. That is your problem. Simple. Okay, exactly. So you can see here, the first thing is cat. So cat is a suffix of this string, and cat is itself present in S1. So means cat is one of the string. We have dog. You can see dog is the suffix of this string. That is why dog can also be considered. But rat is not present in any way. It's even not a suffix and not a prefix in the S1. That is why we will not count rat. So guys, whenever the term prefix and suffix comes in strings, it's a most probably the thing is that we have to use try, because try is very easy and very efficient when we have to match for the prefix and suffix of a string. So let's say what is a try. So guys, try and basically try in strings is something, a simple tree that has 26 children. Usually 26 if we just consider it from A to Z. Why 26? Because there are 26 alphabet. So like initially the node of a try is a blank string. Then we have 26 children like for A, B, C, D and up to Z. And then every children had its own. And when we have lot of strings, array of string, we use that strings, we insert that string in a try and the whole try is created. Let's see how. Okay. See guys, what will happen is, let's say we have these three strings with us, okay? Or let's have a different thing. Let's say we have a cat, dog, we have a cat doll, we have a cation. So I'm just taking all the from C. Let's take something from, let's say we have also fog and we have a frog. We have these strings with us. Okay. So what will happen? Let me erase this one. I don't want much. Okay. Great. So see, let's say these are some strings that we are having with us. So my tree will start from a blank string. First, it will go for C. Then from C, we have A. Then from A, we have T. You can see cat is common in all three strings. Now, when we have a dog, and here we have a cation. So a different branch will be created. For fog also, F, then O, G, and here we have frog. So this is how you can see that a try is created. You can use anything, Nakach. You can take a fixed array of 26 also, because the template that I have taken, it is taking a fixed array of size 26. That is why I'm preferring map. By the way, you can use map also. You can use anything. Like there are multiple implementation of stack. That's on you. It's not like you have to implement using array only and map only. Okay, that's on you in how you are implementing it exactly. So that is what we have to do. So you can see here that I have taken a template for try, where we are having our fixed size 26, because we know that this particular string is having just small alphabet letters. We have just 26 letters. Okay. Now, whenever I will initialize a tree, all the childrens will be null. Initially, all the children are null. I'm assuming this. Whenever I have to insert a children, I first go, let's say this is the thing given, okay? And I have to insert a value, let's say camel. Okay, so I will start from here. First of all, I will search for C. Is there any C present? I will go. Yes, it is present. Then I will search for A. A is also present. Then I will search for M. Is M present? Yes, M is not present. So I will add one more called M, L, and E. This is how a new value is taken. And just similar for search also. Let's say we have to search for the string cation, whether cation is present or not. We have to search whether cation is present or not. So what I will do? I will simply start from the node, root node. I will first search for C, then A, then T, I, O, N. And I can say yes, cation is present. And we also have a thing called the end. Like here a string is ending, or cat or here a string is ending. So that's also a point. Quite complex. Okay? Yeah, it's more optional, but naked, because we know. See. If you will take map, it will be order of n time complexity. Got it? If you will take map, it will be order of n time complex. You don't know, by the way. Okay, but you have to take a but here we are having a fixed size array, array of 26. So if we can take fixed size array of 26, there is no need to use hashing, because map will be hashed. Okay, it takes hash memory. I think you are getting, okay. So because we know there will be only 26 characters, there's no need to take a map. We can do it by this also. Got it? Fine, guys. Is try basics clear? How we create, how we search. Okay. We search, like search and insert is very similar. When we have to insert a number, we also do the same thing. We search till when we get. Let's say for camel, I will search till that part till when I will get that particular character. And when I will say, okay, M is not present, I will add a different root for it. That's all. We add a different root for it. Okay. And you can also use map. It's totally fine. It's totally fine. You can use map. Even when there are 256 characters, map is more efficient. Here also you can use map. I can say that map is more optimal, okay? But that doesn't important, okay? It's not much important. Now, guys, what I will do. So, guys, in this case, what I will do is like you can see these are the things. What I will do, all the values of your S1 list, all the strings of your S1 list, I will push that into my tree. Because what I have to do, I have to search for S2 now. I have to search whether the strings of S2 are present in S1. Whether the strings of S2 are present in S1. That is what we will do. So what I do, all the strings of S1, I will create a try out of it. I will create a try of all the strings of S1. And then simply for each string of S2, I will search whether it is present in that try or not. Are you getting the approach? We will create a try of all the strings of S1, and then using that try, I can search whether a string of S2 is present in that or not. That's all. So now I will first create a try. Okay, I will first take it. Try node. Okay. Root. Okay. And get node. You can see here the get node is a constructor that is used to initialize it. Okay, it was there. Fine. Not a constructor. It's a function. I can say not a constructor. Okay. It was there. Okay. It's here now. For every, what I will do, for every string of S1, I will do for every string of S1, should we insert? Yeah, exactly, research. Exactly. Because we are having prefix also, suffix also. So I will insert the string also and the reverse of it also. Because try only search for prefix. It doesn't search for suffix. It's not possible there. That is why I will insert string also, reverse also. You got it correct, okay? And when you will search for S2, so in searching also, I will search the S2 and reverse of S2 also. Both I will search. Okay, great. You got it. Okay, great. Now what I will do, first I will insert that particular string, like it's string S1I in my thing. Okay, now what I will do, now I will reverse it. So let's say I'm taking a string str, and now I will reverse it. I will reverse that string. Okay, and then again I will insert that reverse string also. That's the thing. I will insert a reverse string also in it. So now I have created a tree out of all the strings of my S1 array. Now I will take a count. I will take a count. Now I will iterate to the S2. And now using the search function. Akash, if you want, I can share with you the code of this in Java also. Okay, in Java also it's very similar. Very similar is there. You know, like in Java and C, there's not much different. Just some basic difference, like in linked list, the nodes say these nodes, and this will be quite different. Like in place of this arrow, there's a dot. That's all. I don't think there is much difference. But because I am not that much fluent in Java, I cannot code it completely in Java. But for sure, I can I can provide you the solution of Java. Okay, that's completely fine. So now I will take a string here. Let's say string str is equal to s2I. Okay, and I will also take the reverse of it. So I will also, like, let's take it as a string reverse, which what I will do, I will reverse the string. Got it? So I will reverse the string. Now I will check whether the current string. See, Matbar, why we are reversing? Because see, what your if you know about try is used for searching prefix, ki whether the prefix is present. But it is not possible with try to search for the suffix. And what is suffix? Suffix is something that starts from the back. So if I will reverse sizing, let's say I'm saying for this camel, MLE was the prefix. I can say this thing. Sorry, for the suffix. And if I will reverse it, so that same thing will become suffix here, but in a reversed way. So that is why what I will do, I am reversing the string so that the suffix will become reverse prefix in that reverse string. And now when I'm searching also, I will search for string also and reverse string also, so that we can check for prefix also and suffix also. Okay. So now I will search if search root comma str is equal to true, or search root comma reverse is equal to true. If any one of that is true, means increase your counter and then return your C. Is it clear now? Okay, exactly. Now you can simply run it. Okay, it should be S1. Yeah, I think it should be fine. Yeah, so it's submitted successfully. Fine. So guys, this is what. So if you don't know the, I can say this particular approach of try, because try is the prerequisite of this problem. So if you don't know try, I have tried my best to have some like I can say to have some. Just give me 1 minute. Yeah, so I tried my best to have like some intro of try, okay, from my side. But even obviously, like try is a very big topic. I cannot explain you the whole concept of try in this slide. So for that, if you don't know about try, what is try, I will recommend you to first learn that, have some basics of try, and after that, if you try to solve the problem, you will completely get it. Okay, that is why how we are solving this particular problem. Okay, so let me share the screen with you all, the code with you all. So like this is the C++ code, and if you want I can also share the Java code. So first let me share the C++ code. Yeah, so guys, here is the I conduct Akash these classes at 6 daily. Okay, these are POD classes. Okay, problem of the day classes which are conducted daily at 6 p.m. Okay, and just give me 1 minute. I will also share the code for Java. Okay, so this was the C++ code. The Java code. Just give me 1 minute. Oh, thanks, Akash. So this is the Java code. If you want to like see the Java code, I can for sure share that with you also. Like in Java code also, we are doing nothing much, but the way how try will be created is quite different, because in Java we have to use string builder in place. Otherwise, the whole concept, the whole logic is exactly same. Just the way how try is implemented is quite different. Otherwise, every concept is same in try also. The time complexity and space complexity already given here. Okay, you can see the try is taking the space and time complexity, but not much. Okay, so it's like the whatever is the length of the whole string, the maximum of it will be the answer. That's all. Okay, so that's what we are doing here. So let's meet again with the next problem of the day, which is tomorrow. Tomorrow also I will be there at 6 p.m. for you guys for next problem of the day. Till then, guys, thank you for today's class. I hope you have got this particular problem. Thank you. Have a good day. Great. Happy coding. GFG कर लो हो जाएगा.